Glenda, Helga, Iona, Julia, Carl, and Lou participated in the 2017 Canadian Team Math Contest. On their team uniforms, each had a different number chosen from the list 11 through 16. Helga and Julia's numbers were even, Carl and Lou's number were prime, and Glenda's number was a perfect square. What was Iona's number? Glenda, Helga, Iona, Julia, Carl, and Lou. Okay, Glenda's number is a perfect square. So of these, the only perfect square is 16. So that obviously is Glenda's number. Carl and Lou's numbers were prime. Of that list, the only prime numbers are 11 and 13, so those numbers are assigned to Carl and Lou. And then Helga and Julia's numbers are even. The only even numbers remaining are 12 and 14, so those must be assigned to Helga and Julia. So the only number left is 15, and that must be assigned to Iona. So number 10, the answer is D. Which integer is closest in value to 35 over 4? 35 over 4, you can do that in your head or in the calculator, is 8.75. And the integer closest to that is 9. So number 7, the answer is C. Which of these numbers gives a remainder of 3 when divided by 5? This would give a remainder of 1. This would give a remainder of 4 when divided by 5. This would give a remainder of 1, remainder of 3, remainder of 4, when divided by 5. So they're looking for a remainder of 3, so that is D for number 4. The product 8 times 48 times 81 is divisible by 6 to the power of k. The largest possible integer value of k is 8 times 48 times 81 divided by 6 to the power of k. 31104 over 6 to the power of k. So we have to figure out what power of 6 can go into this. Okay, let's experiment. If it's 6 to the power of 5, it's 7776. Okay, well, what is 31104 divided by 7776? It is 4. Okay, that's good. How about 6 to the power of 6? That is 46656. So 31104 divided by 46656. Well, obviously that's not going to be an integer. That's a fraction. So that's no good. So the largest value of k for which this is divisible by 6 to the power of k is this guy right here, 5. Number 8, the answer is C. How many positive whole numbers, including 1 and 18, divide exactly into 18? So basically they're asking us what are the factors of 18. Well, 18 itself, because 18 divided by 18 is 1. 9, because 18 divided by 9 is 2. 6, 18 divided by 6 is 3. 3, 18 divided by 3 is 6. 2, 18 divided by 2 is 9. And finally 1, 18 divided by 1 is 18. So these are the factors, and how many are there? 1, 2, 3, 4, 5, 6. So number 3, the answer is D. When 3 consecutive positive integers are multiplied together, the answer is always. Let's just take the first 3, and the answer should be the same regardless of what 3 consecutive positive integers we choose. So let's just choose 1, 2, 3. If I choose 1, 2, 3, their product, which is what happens when you multiply them together, is 6. Now let's look at the answer choices and compare it to 6. The answer is always odd. Well, 6 is not odd, so A is wrong. B, a multiple of 6. Okay, that's good. We'll keep that. C, a multiple of 12. Well, 6 is not a multiple of 12. D, a multiple of 4. 6 is not a multiple of 4. E, a multiple of 5. 6 is not a multiple of 5. So by process of elimination, the answer is B for number 8. Which of the following is a multiple of 7? So 7 times something is equal to one of the answer choices. So let's say 7 times 10, that's 70. Well, 70 is not one of the answer choices. 7 times 11 is 77, and 77 is choice C. So that's really all that is. Number 3 is C. The Gauss Candy Company has 8362 lollipops to package. They place exactly 12 lollipops in each package. How many lollipops remain after the maximum possible number of packages are filled? So you're taking all of these and you're going to put them into packages of 12, right? So 8362 divided by 12 is how many packages? And that number is 696, but it's not exactly 696. It's 696 with a remainder of 10. So when you package all these, there will be 10 left over that cannot be packaged because each package has to have 12. So how many lollipops remain after the maximum possible number of packages are filled? The answer is 10. So number 10, the answer is 10, and that is choice E. How many positive two-digit whole numbers are divisible by 7? We are therefore going from 10 to 99 in our range because it has to be two-digit. Well, the numbers that are divisible by 7 are multiples of 7. 7, 14, 21, and so on, right? All the way up to 70. Obviously, that's 10 times 7. And then 77, 84, 91, 98, and then that's it. After that, we'd get into three-digit numbers. So we have to count how many these are. Well, until 70, it would be 10 if we include that 7, but we're not including the 7 since it's a one-digit number. So these are just 9. There's 9 of those guys. And these, we can just count them. That's 4. So there's 9 here, 4 there. That's a total of 13. So number 7, the answer is E. The positive divisors of 12 other than itself are 1, 2, 3, 4, and 6. Their sum, 1 plus 2 plus 3 plus 4 plus 6, is greater than 12. An abundant number is a number for which the sum of its positive divisors other than itself is greater than the number itself. This means that 12 is an abundant number. Which of the following is also an abundant number? Let's do the same process for each of these and let's figure it out. First of all, let's list the divisors other than itself. So the divisors here would be 1, 2, and 4. Can include 8. Now let's get the sum, and that sum is 7. Is this, or rather, is the sum greater than the number itself? Because that's the definition. The sum of the positive divisors is greater than the number. Well, the sum is 7, the number is 8, so no, that's not true. 7 is actually less than 8. Okay, let's keep going. Here it's 1, 2, and 5. The sum is 8. 8 is less than 10. So again, not abundant. Here the positive divisors are 1, 2, 7. The sum is 10. 10 is less than 14. 18. 1, 2, 3, 6, 9. The sum is 21. 21 is greater than 18. So that means 18 is the abundant number of the list of answer choices. Number 10, the answer is D.